Hi students, this is Mr. Clucky here. I'm going to go ahead and we're going to discuss the orientation of our magnets in the direction of those magnetic forces, and then in the end we'll make a prediction before we do our lab investigation regarding the direction of the force in those magnets. So I'm going to make my video a little bit smaller here and shoot me off to the side, and then I will go ahead and present our slides so that we can see all of those in general. All right, so on this slide, if I make me go up there a little bit. All right, so on here, I want to just go ahead and talk about our system here. So in this picture, you'll notice we've got a magnet and a compass. And before we discuss the system between the two things, we need to talk about this compass. And we've seen those before. Remember, we used compasses to see if a magnet was attracted to them in our investigation back in lesson 2 about what kind of magnet push and pull. So we've seen the compasses before, but just as a reminder, a compass needle, so specifically we're going to talk about the needle in the compass. That needle is a permanent magnet on a pin. Right? The pin allows the permanent magnet, which is the arrows, to rotate so that it can line up with the direction of the forces in a magnetic field. So the only magnetic part of the compass is that compass needle. And that compass needle is actually what we're going to call a permanent magnet. It's made out of iron, but it also will attract and repel objects. So again, there's a pin in there and allows it to rotate so that it can line up with the direction of forces in our magnetic fields. Now, real quick, thinking about that, I want you to talk about this question, and I'm going to put it as a question into our Edpuzzle here, but which end of the compass needle is the North Pole, and how do you know? So looking at this compass right here, which end is the North Pole, and how do you know? All right, so thinking about that for a second, we know that the compass is labeled, right? And on here we can see that there's a red arrow and there's a silver arrow. And we're going to know that the compass needle, the end of the compass needle that's North Pole, is the one that's going to aim right to the north. So notice we've got our directions on here, north, east, south, west. When the needle aims towards the north, we know that that part of the compass needle is the North Pole. All right, so these directions on our compass, when the needle aligns with those, that's going to show us where north is at. Okay. Now, what I also want to do is I want to quickly introduce the terms North and South Pole. Okay, so you might notice that many magnets are marked with an N on one end and an S on the other end, and those terms mean North and South Poles. Okay, so we are going to use those words to keep track of which end of the magnet we're referring to. Okay, so the North and South Poles are similar to what we might see with like the Earth, and we might draw some connections between the Earth and a magnet and the magnets we use in class. But just like the Earth, where there's a North and South Pole, we will also indicate two ends of a magnet, keeping them separate by indicating them also as North Pole and South Poles as well. All right, so before we move further, another question I wanted to think about is, why is it important to keep track of which end of the magnet is which? Right, why might that be important? Okay, well, I want us to think back to lesson 2. So remember in lesson 2, when we put stickers on one side of the magnet, and this was when we did the electromagnet. We put a sticker on one side of the electromagnet, and we put another sticker on the other side of the permanent magnet, and we were essentially labeling those so that we could not forget which end was which, right? And we noticed that one end attracted and one side repelled. Well, the reason we did that is we want to know which side is attracting, which side is repelling. And basically, we're going to remove those labels that we would stick on there, and we're going to just call them North and South Pole. So from now on, we can use North Pole and South Pole so that we know when the magnets will attract each other and when they're going to repel each other. All right, and one way to say that is that similar poles, so a north and a south and a south, similar poles are going to repel each other. And when poles are opposite, like a north and a south, excuse me, when we have opposite poles like a north and a south, those two poles are going to attract each other. So now in your notebooks, we're going to go ahead and we're going to complete this prediction. So in your notebook, I believe this should be on page, I can't remember. This should be, it's listed on your Google HyperDoc, but this prediction, I believe, should be on page 36. Well, I've got the sneezes today. This prediction will be on page 36, but I want you to look at the slide, and it says, we've got a magnet here with the North and South Pole, and you see that we've got these different locations, A all the way through E. I want you to draw this situation in your notebooks, And then I want you to draw an arrow for where you predict the magnet, or not the magnet, where you predict the compass needle will point. So just to read this, which way would the north pole of the compass needle, the red end, oh goodness, zoomed away there. Which way would the north pole of a compass needle, the red end, point if we moved it to other locations in the magnetic field? Record your predictions by drawing the direction of the needle that it would be facing when we moved it to each of the locations shown below, which is B, C, D, E. So notice I've given you A. Where do you think it would point in location B, location C, location D, and location E? Copy that into your science notebook, and then we're going to go ahead and do the investigation and see what happens. All right. You guys are good to go ahead and record this, and then I will see you in the next investigation.